Hello and welcome everyone with another video lesson of our platform Data Science Era. And as you can see, the topic of this lesson is Way Anova, very important topic. And in this lesson, I will first show you the concepts of Way Anova, then we will show the assumptions and the ideas, and then we will apply it on SPSS, okay? And then we will learn how to interpret it very clearly. Okay, so before watching this video, make sure that you download the data files I have provided you. If you're watching this video from YouTube, you will get it in my description or maybe anywhere. Okay, so let's start the idea. So what is one-way ANOVA? One-way ANOVA is actually a hypothesis test. Okay, it is also called like analysis of variance. And the important thing to remember is that there is one dependent variable which is continuous, okay, and also one independent variable which is also known as factor. That is why ANOVA is also known as one kind of factorial analysis. Okay, so and the dependent independent variable may have two or more than two categories. Okay, usually more than two categories. So when it have like two categories, it's actually is equivalent to independent sample t-test. Okay, so if you are actually confused about the ideas, let me give you one or two examples and with the definition. The definition is like one-way ANOVA is a statistical method to find out the difference between the means. Okay, so here our goal is to find out the difference between the mean of a continuous dependent variable on any two or more than two independent groups. Okay, and to discuss this more elaborately, let's consider one or two examples. So here is the example. Let me say the independent variable is say programming test score, okay, which is actually a continuous variable. And also let us say there is an independent variable like academic grades in category. Let's say which has three category: high CGPA, medium CGPA, low CGPA. And what is our goal is that for high CGPA you will get a mean of test score, right? For medium CGPA you will get another mean of programming test score. For low CGPA you will get another mean of programming test score. And at last, let's say you want to determine whether these three mean has any significant difference or not. Okay, so you must have some question, okay, why should I conduct this study? Well, it is actually, let's say that it may possible that students who do not have a good CGPA but are very good at programming, so that is why you need to compare the mean of with these to the medium or high CGPA. Okay, so we will discuss this with the data set we have in SPSS. Now let us discuss another example. Okay, so here you can see that let's say our dependent variable is like bone density, okay, and the independent variable is like smoking status, which has two categories: smoker, non-smoker. And for a smoker you will get a mean of density, for non-smoker you will get a mean of density. Okay, now at last you need to find out the difference. Now a lot of people might think that okay, I can find the mean directly and I can compare them. Then why should I do this hypothesis test? Well, I hope you guys remember the ideas of inferential statistics, where we do not know about the population. What do? We collect the data from a sample, then comment on the population. So when you are making a comment on the population, you are not actually 100% sure. Whatever you are interpreting or saying is all about the probability or prediction, okay? So here, that is why you have to do a hypothesis test to have a clear idea whether the difference is significant or not, whether your sample represent the population or not, so that you can tell whether there is any mean difference. Now let us go with the process that how we're gonna do that. Okay, so here you can see that let's say that at group 1, for low CGPA you got a mean score. For group 2, for medium CGPA you got a mean score. For group 3 you got another mean score. And the first thing you need to do an ANOVA test. And if you find out that there are significant difference in their mean, then you can do a post hoc test to check out that which pair have the significant difference. It may be between low versus medium, it may be between medium versus high, it may be between low versus high. Okay, so you never know. So this will help you out. But to do this test, you need to find out at first the ANOVA test whether there is significant difference or not. If there is no significant difference, you do not need to do any kind of post hoc test. Okay, so that is the idea and process all about. Now let us move with the assumption. Okay, so there are three assumptions. The first one is for there should be no outlier, then second one is for the it should follow normality, and the third one is to check out the homogeneity of variances in the data. I hope you guys remember the ideas as I already discussed this in some other videos. Okay, so now let us open our data file. Please download the data file. Here is the data file. Look at this very carefully. Here we have two variables. The number one is programming exam score and the number two is student CGPA group, which has three categories. Okay, so what we will find out, we will find out that let's say for medium CGPA will get a mean for these five values, right? For low CGPA will get a mean. So we will do this in SPSS in terms of the process. Okay, so the first one is to check the assumption of outlier. I hope you guys remember how to check outlier. To check outlier, you need to draw a box plot. Okay, and to draw a box plot, go to the graphs, then go to the chart builder, and then click OK. So here you got a box, right? Now we just need to click in the gallery option, box plot. Okay, and select the first box plot. And in the x-axis, select the categorical variable. So it has three categories. You will get a 3 box. In the y-axis, select the continuous variable, which is programming score, right? And then click OK to get your desired output. Now the output, you can see there is no circle or no point outside the box, right? No point. There should be a point outside the box if it has any outlier. So there is no outlier in the data. Well, if you have outlier, you can try to remove it, or maybe alternatively, if any one of assumption is not fulfilled regarding normality or homogeneity of variances, you can try out the non-parametric test. Okay, so non-parametric test is actually alternative of Way Anova. We will discuss on another video. So now let us go for the second assumptions, which is normality test. Okay, so to do normality test, go to the analyze, then click describe to statistics. Okay, and then click the explore, and you will got a box, right? So in the dependent list, you need to check out the dependent variable, which is programming exam score. Just drag it here, and then just drag it in the factor list. Okay, which is our independent variable, and it's a categorical variable because it has 3 categories. And then go to the statistics. You do not need to do anything. If you can avoid it. If you want to check the descriptive, you can click it out, and then click continue and click the plots. Very important one is the normality plots with test. Okay, so click it, and you do not need to check the stimuli plot here, so you can just avoid it. Also, you do not need to check the box plot, so click none, and then click continue. At last, click OK to get your output. Okay, so now let us interpret the output here. We gotta interpret the output in our slides, and here you can see that here we are actually considering Shapiro-Wilk test. I will remember it is more appropriate, especially for a small sample size. For large sample size, you can check out the QQ plot also. Okay, so here you can see for this test, the null is like it follows normal for CGPA groups. Okay, and here you can see all the p-value here are greater than 0.05. So you can say that the null is accepted at 5% level of significance. Okay, so we can conclude what? We conclude that it follows normal. What it is the distribution of programming score in different CGPA groups. So we are done with our second assumptions. Now let's move forward with the third assumption, which is homogeneity of variance. Interestingly, you'll get the output of this assumption when you check the final output. That means the final output of ANOVA. So you can find the both at the same times in SPSS. Okay, so to get the third assumptions and our final output of ANOVA, go to the analyze and click compare means, then click one way ANOVA. Okay, and then just drag it here and also drag the categorical in the factor option. Okay, and there's a lot of options like contrast, you can avoid it. Like options here, you need to click the homogeneity of variance test. Okay, you can also click the descriptive if you want to check out the exact mean and other things. And there are a lot of post hoc tests which you can check out. Like let's say here we are interested for checking the Tukey test. Okay, so there are a lot of things to discuss here. I'm discussing only the primary things so that you got the whole idea in terms of the definition or the interpretation or other things. So click continue and click OK to get an output. So you got an ANOVA here. First you need to check it out. If there is a there is a significant difference, then you can go to this table, multiple comparison, which is post hoc test. So and before that you should have checked the third assumptions. Okay, so copy these three table and let us interpret this in our slides more interactively. Okay, so here you can see our null is like for this homogeneity test is that there exist equal variances. That means there exist homogeneity of variances at our null. So our goal here is to accept the null and look at the p-value. This is very high, which is greater than 0.05. So our null is accepted at 5% level of significance. Why 5% here we are considering? You can consider 1%. Then you need to check it out for 0.01. Okay, a level of significance is actually telling you that how much error you're gonna accept. Okay, how much error is you gonna determine. I'm just telling a general language rather than telling statistical language. Okay, so here the p-value is accepted, or should I say the null is accepted, and then you can conclude that there exist homogeneity of variances. So our first three assumptions fulfilled. So now we can check it out the one-way ANOVA test. Okay, so you must have got the output here. Okay, you got the output table in the SPSS output. So here you can see null is like that the mean programming score for three CGPA groups are equal. The alternative is like mean programming score for three CGPA groups are not equal. Okay, so here you can see that the p-value is less than 0.05. So if the p-value is less than 0.05, we can take out the decision that the null is rejected or cannot be accepted. So we can say that the mean programming score for three groups are not equal. So here you got the final output. Okay, now let's say you want to check out the post hoc test. Here we are using the Tukey test. Okay, which is a very good test for finding the output or for comparing the pair. Okay, if you forgot the idea, we got all this output here. Okay, I'm just copy this output and showing it that how you can interpret it. Okay, so copying this table. Now let us show this. So yeah, so the here we have three null and alternative. The first one is for group 1 and group 2. Let's say group 1 and group 2 are like high CGPA and low CGPA. Okay, you can consider anyone. So the mean programming score for high and low are equal. That is our null, and alternative is that not equal. And another null alternative is for like high CGPA and medium CGPA. And the last one is for medium and low CGPA. Now let us interpret this by using this table. Okay, so here you can see that the p-value for every two groups. Okay, let us compare the high versus the medium. Okay, high and medium, how much you got? You got the p-value is 0.000. So it is less than 0.05, and we can conclude that the mean programming score, high and medium, are not equal. Okay, and then for the high and low CGPA, it is like very high. So here the null is accepted. That means there is no difference between the high CGPA and the low CGPA. Okay, and the last group to consider, the medium and the low, which is also 0.000. So you can consider that the medium and low CPA groups means are not equal. Okay, so yeah, that is what the concepts of ANOVA. Remember that here we usually have around 3 groups, and our goal is to do the mean test. Okay, because we are dealing with sample data, and when you want to comment on the population, you must use a hypothesis test. You cannot do it directly. Okay, and there are also a lot of tests. We have 2 ANOVA, 3 ANOVA, and interaction are a lot of things to discuss. Okay, so yeah, maybe we'll come with another video on another day. And also, like, when the alternative of this test, I also mentioned that if you audit that, okay, the assumption is not fulfilled, what should I do? Maybe we'll discuss it with another video of non-parametric test. So yeah, so till then, see you everyone. And also I want to let you guys know that you can join our WhatsApp group, our Facebook group, and also you can subscribe to my YouTube channel to be notified for every single videos. I will upload videos regarding SPSS, R, Python, and a lot of statistical conceptual video. Okay, and you can also, like, join our website www.datascienceera.com. So yeah, goodbye everyone. Ta-da.